Hello everyone, welcome back to my YouTube channel. Today we are diving into the abstract factory design pattern. This is one of the creational design patterns in object-oriented programming, and it's a powerful tool for managing related objects without specifying their exact classes. So let's get started. So abstract factory design patterns provide an interface for creating families of related or dependent objects without specifying their concrete classes. It's useful when our system needs to be independent of how its objects are created, composed, and represented. So, here we are talking about related objects. What I mean by related objects? Okay, so here we have three categories: Apple products, Google products, and Samsung products. Under Apple products category, we have Apple phone and Apple tablet. Under Google products category, we have Google phone, Google tablet, and so on. So here, Apple phone and Apple tablet, they are related objects, or we can say both these products belong to the same family. So basically, both these products belongs to the company Apple. So that's why we are saying these products belong to the same family. So similarly, Google phone and Google tablet, they belong to the category Google products. So we can say these are the related products, or we can say these products belongs to the same family, and so on. So here we are talking about abstract factory design pattern, which helps us to create multiple objects of same family altogether. Okay, so to better understanding, so let's take an real world example. So let's imagine a scenario in an electronic store. For instance, if client says, I am interested in Google products, right? The store staff would immediately present the Google phone, Google tablet, and maybe even a Google watch, right? On the other hand, if the client prefers Apple products, the staff would bring out an Apple phone, Apple tablet, and Apple watch, right? So this approach ensures that the client sees a consistent set of products that align with their preferred brand, right? The store doesn't mix products from different companies unless the client asks for it. Now think how we can apply this concept in software development. Just like the store staff selects the right set of products based on the client's preference, right? The abstract factory pattern allows us to create a family of related objects like phones, tablets, and watches based on specific company without having to specify the exact classes. So this is what abstract factory design pattern is. Okay, now that we have seen how this works in the real world, let's take a look at how we can implement the same scenario in coding, or we can replicating the same approach for Google and Apple products. So here in this diagram, you can see, so we have Google phone class, we have Google tablet class, we have Apple phone class, and similarly we have Apple tablet class. And here we have client code. So basically we have created one class device store where we have references of all our classes, and whenever the constructor of device store would be called, so on the basis of company name that is passed in constructor, on the basis of that we will be creating the related objects, right? So I am replicating the same example in coding. So in this example, we will see how we are violating abstract factory design pattern, because to understand abstract factory design pattern, we need to see like what are the problems uh, with the normal approach of development, and what are the benefits of using abstract factory design pattern. So let's jump into the coding. Okay, so here let me create one package. Let's name it bad, so for bad design. And here I'm creating one class Apple phone, and in this class let me create one method public void call, and for the time being I'm just printing the message calling from Apple phone, right? Similarly, I'm creating another class Google phone, and here public void call calling from Google phone, right? I'm creating another class Apple tablet, and here I will be creating one method public void browse, and let's print browsing from a Apple tablet, browsing from a Apple tablet. And let me create the last class here, that would be for Google tablet, and here we have method public void browse, and let's print browsing from a Google tablet, right? Now we have four classes for four of our products, right? Now let me create one class device store, right? And this class will be containing the references. So you can see in this diagram, so this is the client code device store, so that will be containing the references, and we will be initializing the products on the basis of past company name. So private Google phone, private Apple phone, private Google tablet, and similarly Apple tablet, right? So let me create the constructor public device store, and in this constructor we will be passing the company name or brand, and on the basis of past company name, so if company dot equals ignore case Google, then we will be creating Google phone and Google tablet, right? Similarly, if the company name is Apple, in that case we will be creating products of Apple category, right? And let me create another method. We can say public void show devices, right? And that time we will be checking if Google phone not equals to null, so it means so we have already initialized the Google products, and in that case Google phone dot call and Google tablet dot browse, right? Else if Apple phone not equals to null, Apple phone dot call Apple tablet dot browse. So we have created a class device store, and we have initialized the various products, and finally we have just a show method to call or browse, right? So let me quickly create main class, main method. here, for example, device store equals to new device store. For example, I passed here Google, sorry, and if I say store dot show devices, so in that case, if I run this program, so we got the output calling from Google phone, browsing from a Google tablet, right? And if we pass Apple and run this, so calling from Apple phone and browsing from Apple tablet. So this code looks good, but it is not following the correct abstract factory design pattern. Okay, so in this class, you can see, so device store class is tightly coupled to a specific concrete product classes like Google phone, Apple phone, right? Or Google tablet or Apple tablet. This makes it difficult to add new companies or products without modifying the existing client code. So for example, in future, we want to add another brand, say it Samsung, right? So if we want to add Samsung phone and Samsung tablet in this class, so we will have to modify this class, right? So that is not a good approach. Another thing is duplication code, right? So you can see for various brands, so we have written the similar kind of code. So for Google, so we have written one if case here, and we are initializing the Google products. Similarly, for Apple, again we are initializing the Apple products. And if we have, for example, 5 products, so we will be writing the same code 5 times, so which is not a good programming practice, right? Another drawback of this approach is to, like, it's very hard to extend, like as I mentioned earlier, to support a new company, for example Samsung, right? Our class would need to be modified to include new product classes, right? Which is clearly violation of open closed principle, which states like our code should be open for extension and closed for modifications, but we are modifying the code, means we are violating the open closed principle. So in this example, the violation of abstract factory pattern results in a design that is less flexible and harder to maintain, right? The client code, which is basically the device store, right? So let me jump onto the diagram. The client code, which is our device store class, right? That is directly depend on specific product classes. So it is making it difficult to extend the system with new companies or product types. The abstract factory pattern would help by decoupling the client from the specific implementations and making it easier to introduce new companies and products without modifying existing code. So let's refactor our code to use the abstract factory design pattern and see how it solves the issue. So here in this diagram, so let's try to understand step by step. So the very first thing is, so our classes like Apple phone, Apple tablet, Google phone, Google tablet, these were not be independent at all. So we will be creating the interfaces first, and so these classes will be the implementation of these interfaces. Okay, so let's jump into the code side, and we will be trying to understand this diagram step by step with coding. Okay. Okay, let me create another package that is for good design. So let's call it good. And here, first thing I will be creating one interface that is called phone. And here we will be having one method void call. Similarly, I am creating another interface tablet, and we would be having one method here void browse. So here call and browse. Now we will be creating the concrete classes. For example, Google phone, that is implementation of phone interface, and public, sorry, void call, calling from Google phone. Right. Similarly, let me create Apple phone, implements phone, public void call, and finally calling from Apple phone. Okay, let's create class Google tablet, implements tablet, and public void browse, and here browsing from a Google tablet, right? And the last concrete class here is Apple tablet. So implementation of tablet, implements tablet, and public void browse, and browsing from an Apple tablet, right? So we have interface, phone and tablet, and their respective concrete classes for various brands. Now let's jump onto the diagram. Now we need to create one interface device factory, which will be containing two methods, create phone or create tablet, and which is not directly depending upon the concrete classes like Apple phone, Apple tablet, Google phone, or Google tablet, but it will be returning the references of the abstraction of these concrete classes. Those are the interfaces, phone and tablet. So let's create device factory abstract class or interface. So here I am creating one interface called device factory, and here we have two methods, phone, create phone, and tablet, create tablet, right? So we have created this interface, so which is not depending upon the any concrete implementation of uh, these products, but it is depending upon the abstraction of these concrete classes, that is phone and tablet interfaces. Now from this device factory, right, so we will be creating various factory classes on the basis of various brands we have, right? So for example, for this, for creating actual Apple objects, right, so we will be having Apple factory, so which will be creating the objects of Apple phone and Apple tablet respectively. Similarly for other brand, so we have Google factory, which will be creating the objects of Google phone and Google tablet. So let's create these two classes. So what, first one is Google factory, that is the implementation of device factory, right? And here we need to implement two methods, create phone and create tablet. So we will be creating new Google phone and new Google tablet. Okay. Similarly, just like Google factory, I am creating Apple factory. That is again implementation of device factory. And here I need to implement create phone and create tablet methods. And because this is Apple factory, it will be creating Apple phone or Apple tablet, right? Let's jump to the diagram one more time. So we have completed the left side, uh, concrete classes, interfaces, and our device factory interface, also Apple factory and Google factory. Let's jump onto the client code. So in this code, you can see we have device store class, and with the abstraction of phone and tablet. So we are not directly tight coupling the concrete classes, but we are using their abstraction, and we are initializing these references in our constructor. And finally, in show devices, we will be calling their respective methods. So let's create this class quickly. So here we have class device store, right? And let me create the references. Private phone. So it's not any specific phone, but it's the generalized phone. And private tablet, right? And inside the constructor, public device store and device factory. So we will be passing the reference of device factory. Again, here device factory is also the abstraction. So let me jump onto the diagram once. So we are not passing any concrete implementation of device factory, but we are using the abstraction. So that it can, so that this constructor can accept any factory. It can be Apple factory or it can be Google factory, right? So we are making our client code more generalized so that it will not be dependent on any concrete implementation. So here we passed device factory, and we are initializing phone by calling create phone method from the device factory. So if this device factory contains the reference of Apple factory, then the respective create phone method will be called, and this reference will be containing the Apple phone, right? And if device factory is reference of Google factory, then by calling this method, we will be getting the Google phone object, right? And similarly, tablet equals to device factory dot create tablet. Okay. And for example, we have method show devices or present devices, and from phone we are calling call method, and tablet we are calling browse method. So whatever the reference this phone and tablet will be containing, so respective call and browse methods will be called. So finally, let me create main class. Okay, so in this main class, let me create the main method. Okay, so for example, in this class, uh, either we can take user inputs, or for the time being, I'm just creating one variable string company equals to Google, right? And here, if company dot equals ignore case Google, then I need to do one thing here. I need to create device factory, right? Because we need to create device factory first, and we need to pass it to our device store. So we have this device factory here. If company is Google, then factory is new Google factory, right? And else if company is Apple, then factory will be new Apple factory, right? So finally here I can do one thing here. So let me create another case, else throw illegal argument exception. Because if our current application supports Google and Apple, right? So in place of Google or Apple, if we are sending anything else, so we will be getting the invalid company exception. And finally, so we have device store equals to new device store, and we need to pass the factory. And again, this factory can be either Google or Apple on the basis of the company, right? And here if I call store dot show devices, so this will be calling the respective call and browse methods as per the selected brand. Now in this approach you can see, so here is the client's input. So just we discussed the real world example where client shows his interest in Apple products or Google products. So that is the similar input. So if the selected company is Google, on the basis of this input, so we are creating the instance of Google factory, and in our client code, which is 100% generalized, okay? So in this, so this device factory will be containing the object of Google factory, and on the basis of that we will be calling create phone and create tablet, right? So here in main class I am running this program. So you can see calling from Google phone and browsing from a Google tablet. And if I select Apple and run this program, so calling from Apple phone and browsing from an Apple tablet. So now this diagram is easy to understand. So how our design factory helps to make the code more maintainable and scalable. And that's how the abstract factory pattern can solve the problem of tight coupling in our code. By using this pattern, we make our code more extensible and maintainable, so which allows for easy addition of new product families without altering existing code. Now think, so in this all diagram, for example, I want to introduce Samsung products. So there would not be any change in client code, but just we will be adding additional factory, that would be Samsung factory, and additional concrete implementation of phone and tablet interfaces, right? So that would be the addition, that is not the modification. So we are not violating the open closed principle as well. So I hope I have tried my best to make you understand how abstract factory design pattern works. If you found this video is helpful, don't forget to like, share and subscribe to this channel for more coding tutorials. Hit the notification bell so you never miss an update. Yeah. Till then, happy coding. Thank you so much.